In this video, I will be talking about proving remainder theorem and factor theorem. So let us tackle first remainder theorem. What does this remainder theorem state? The remainder theorem states that when a polynomial f of x is divided by a linear polynomial, that is x minus a, the remainder of that division will be equivalent to f of a. So what does it mean by this? Let me illustrate it to you. For example, we have these two polynomials, x cubed minus 4x squared plus 2x plus 6. It will be divided by this binomial at the bottom, x minus 2. And your concern is, let's say you are not after the quotient, but you're after of the remainder. You want to know what is the remainder of this. So according to the remainder theorem, for you to make it easier to find the remainder, you just have to substitute these two to the values of x. So that's how you get the remainder. So for this example, so that uh, expression or polynomial, we're going to solve for r. We're going to substitute x by 2. Based on the statement, it's x minus a. So the a will be substituted to x, and the a in the given is 2. So it will be now 2 cubed minus 4 times 2 squared plus 2 times 2 plus 6. So all the x's are changed into 2. And then 2 cubed is 8, 2 squared is 4, and then let us simplify further. So 4 times 4 is 16, and 2 times 2 is 4, and copy 8 and 6. Then we're going to solve now 8 minus 16 plus 4 plus 6. So if you combine all those 4, it will be equal to 2. So that means if we divide x cubed minus 4x squared plus 2x plus 6 by x minus 2, the remainder will be 2. So that's how easy it is if you will use remainder theorem when finding the remainder. Now to make sure that it's really the right remainder, I'm going to show you the long division method and compare the remainder. So here's the given, and we're going to divide this using long division. So here you go, we have x cubed minus 4x squared plus 2x plus 6, and the divisor x minus 2. So we'll divide x cubed by x, so first term by first term, it will be x squared. Then distribute x squared times x is x cubed, x squared times negative 2 is negative 2x squared. Then subtract, x cubed minus x cubed is 0, negative 4x squared minus negative 2x squared, or you can also write it as negative 4x squared plus positive 2x squared, because minus negative is positive. So it will be negative 2x squared. Bring down 2 plus 2x. Then we'll divide again first term by first term. Negative 2x squared divided by x is negative 2x. Then distribute negative 2x. Negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. Then subtract, negative 2x squared minus itself is 0. 2x minus 4x is negative 2x. Bring down plus 6. And then divide again, negative 2x by x is negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Then let's subtract, negative 2x by minus negative 2x is 0. 6 minus positive 4 is 2. So as you can see, the remainder is 2, which is the same as the remainder using the remainder theorem. So let us now prove the remainder theorem. So the remainder theorem is like this. Um, f of x, or any polynomial, divided by the binomial x minus a. So it will be now f of a. So if we substitute a by x, it will be the remainder. And let me show you the proof now. So the one on top is actually the illustration of the remainder theorem. And here's the proof. so that we can show that it is also true to any kind of polynomial divided by a binomial. So the any polynomial can be expressed as this: f of x is equal to the quotient times the divisor plus the remainder. So you might wonder, how is that true? So it is always true, but let me show you an example. For example, let's say the f of x is the 7 and the divisor x minus a is the 2. So if you divide 7 by 2, of course that's not divisible, but we can only have a quotient 3, but 3 times 2 is 6, so there's a remainder 1. That means you can write 7 as the quotient 3 times the divisor 2 plus the remainder 1. So that's 3 times 2 is 6 plus 1, 7. So, but this is numbers. But it's also true when it is written in polynomials. So that's the idea of f of x equals the quotient times the divisor plus the remainder. And that is always true. Now let us continue. And so we're going to substitute a by x. What we are after is to get f of a is equal to the r, or the remainder. So since that's the idea of the theorem, if we're going to change x by a, the f of a must be r. So here we substitute it, and then we're going to subtract a minus a by 0. So 0 times q, or 0 times any number, is 0. Then 0 plus r, or 0 plus any number, is just itself. And here we go, we have f of a is equal to r. So that means if you substitute the a to any polynomial, you will always get the remainder. So this proves that the theorem is true to any polynomial when divided by a binomial. Now let's move on to factor theorem. So factor theorem states that when a polynomial f of x has a factor x minus a, if and only if f of a is equal to 0. So it's actually in relation to the remainder theorem. So what does it mean by that? So let's say you are only concerned with the x plus 3, whether it is a factor of 2x cubed plus 4x squared plus 18. So how will you know that x plus 3 is a factor of this polynomial? So you will know it's a factor if you can form x plus 3 times something, times an expression. It will be the 2x cubed plus 4x squared plus 18. So just like 3 is a factor of 6 because 3 times 2 is 6. So you have 3 times something to get 6. That's why 3 is a factor of 6. So now we're going to use the factor theorem to solve this. So what's the factor theorem is saying? So it says that if you have this f of x, and if you're going to change the x by the a, so you might wonder, why is x negative 3? So if we're going to change all the x by the a, which is negative 3, now you might wonder why it's negative 3 and the given is x plus 3. Because it's x minus a, and x plus 3 can be written as x minus negative 3. Minus negative 3 is actually plus 3. But then since in the formula, I mean in the theorem, it's x minus a, so it should be in that form. So it's x minus negative 3. So if according to the factor theorem, so if we're going to substitute the a to the x, and the result is 0, that means the x plus 3 is a factor of the polynomial. So now let's try to test if x plus 3 is really a factor of 2x cubed plus 4x squared plus 18. So let us substitute. Now let's solve. Negative 3 cubed is negative 27. So it's negative 3 times negative 3 times negative 3. Then negative 3 squared is 9. Then let us solve further. 2 times negative 27 will be negative 54. 4 times 9 is 36. Then we are going to combine all this, it will be now 0. Negative 54 plus 36 plus 18 is 0. So since it's 0, again, according to factor theorem, if that is 0, that means x plus 3 is a factor of 2x cubed plus 4x squared plus 18. That means this x plus 3 can divide that polynomial and without a remainder, or the remainder is 0. In fact, we can write this 2x cubed, this polynomial, in this form. 2x squared minus 2x plus 6 times x plus 3. So as you can see, it is x plus 3 is a factor of the polynomial. So actually 2x squared minus 2x plus 6 is the quotient when you divide the two polynomials. When you divide the polynomial 2x cubed plus 4x squared plus 18 by x plus 3. So that will be the quotient 2x squared minus 2x plus 6. So that's the idea of factor theorem, and where I'm going to prove this factor theorem so that uh, I am able to show that this is not only true to this example, but it's true in general. So let us prove factor theorem. The factor theorem is by conditional statement. It's if and only if, so we have two cases to prove. First is if this is given that they are factors, then it implies that the f of a is equal to 0. And also, the vice versa. If f of a is equal to 0, then it is that x minus a is a factor of the polynomial. That's the idea of if and only if. It's biconditional, so you have to prove both. So let's start with the a. So starting here, f of x is equal to the quotient times the divisor x minus a. So the given is it is the x minus a is a factor, and we are going to show that f of a is equal to 0. So we're gonna substitute a by x by a, and we're gonna find f of a equals 0. So a minus a is 0, and q times 0 is 0. So here you go, you have f of a equals 0, and we have proven the first one, which is saying that if x minus a is a factor of the polynomial, then the remainder is 0. Now let's prove the second one, the vice versa. So if this is given, the f of a equals 0 or the remainder is 0, then the x minus a is a polynomial, is a factor of the polynomial f of x. So that is given, and let's go back to this. This is the true statement, like what I have shown you in the proof of remainder theorem. And then we are going to change the r by f of a, because according to remainder theorem, f of a is equal to r. Since it is given that f of a is equal to 0, then we can substitute f of a by 0. Then let us continue. We can just remove the 0 because it's plus 0. Any number plus 0 is just itself. So that means f of x is equal to q times x minus a, or x minus a is a factor of f of the polynomial. And that is the proof of factor theorem. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.